Hi everybody, it's Peter Rosenthal here. Hope all is well. This is going to be the first of a few mini videos for our lecture for March 4th. I'm going to post 4 of them. Each video is going to be one problem related to statistical quality control, which is chapter 10. So this is the first video. By the way, I hope you had a good spring break. If you're watching this during spring break, well, I hope that you're at least taking a bit of time off and you're relaxing a bit, which is, I'm sure, very well deserved. And also, I hope that you found the midterm okay. I'll certainly talk a bit more about that when we get back together in class. Next time we have our next lecture. So it's Peter Rosenthal. Here's a picture of me, by the way, just to remind you a little bit what I look like. It's a picture of me on an Air Force base working part of my day job. So that's about it. What I'm going to do here is I'm going to spend the next 15 minutes or so to go through problem 1016 in chapter 10. That's problem 1016 in chapter 10. And we'll go through it just like we do in class, one step at a time. And as always, if you have any questions, by all means, you can send me an email to get in touch with me, and I'll get back to you as soon as possible. And if I have to, we can even arrange for a telecon, so not a problem if you have any question whatsoever. Okay, so let's get started. The first point is that I would like to, before we start to discuss the actual problem, just a refresher. This is from last lecture, last class, just to talk a little bit about the formulas that we use for the control charts. So the first kind of control charts are the X bar and R charts. The X bar and the R charts right here. The formulas that we use are as follows. We, of course, want to compute an upper control limit and lower control limit. And there's two forms of the formulas for the X bar chart. And you can see here one type uses the standard deviation if it's given in the problem. And another type of form uses constants which are given in a table. And it's quite straightforward to determine what your constants are. And we're going to do both types of questions. So not to worry, we'll go through step by step how to find that out. And for the range charts, we have no choice, but we have to use, in fact, these constants which are available from the chart. The chart is in the textbook. It's table 10.2 on page 330, so you can take a look at that. Over here it describes basically what the different variables are, and maybe just a keynote here. Key point is that usually the standard deviation of the process right here, usually it's the standard deviation of the process which is given as opposed to the standard deviation of the sampling distribution. So usually in these problems what you do is to calculate your upper control limit and lower control limits, you want to use this formula here to plug into this sigma here. So basically what you do is you're given the sigma of the process, divide by the square root of the sample size, n, and you're ready to compute your upper control limit, lower control limit. Again, don't worry, we're going to do a problem. I'll show you exactly what I mean by that. Okay, and just a brief note here, we also talked about last class the P charts. So this will be the subject of the next video, but just as a refresher, it's very similar. We calculate the P over here from the data in the problem, and it allows us to very quickly compute our upper control limits and lower control limits, and then we plot our charts and we're able to complete the question. Okay, and also I wanted to show you this. This is just a snapshot from the textbook. This is the table 10-2 I was telling you about on page 330, and the way it works is that you take a look at your sample size right here. So depending on your sample size, let's say your sample size is 5. Last class we had a sample size of 5, if you remember, in the problem that we did. So if you take a look at sample size 5 right here, it gives you the factors for your upper control limit and lower. So this is the A2 that you use in your upper control limit for the X bar chart and lower control limit for the X bar chart. And these are the factors that you use for the range charts right here. Okay, so we'll do a problem like that and you'll see exactly how we are supposed to use that. All right, so let's get to that. Okay, so the next step is, let's just review the problem itself. So this is problem 1016 in the text. It's also posted on Moodle, which it's been there for a while, so nothing new here. But let's look at the problem. So we'll read it together. It says, a technician in a quick oil change shop had the following service times in minutes for 20 randomly selected cars. So if you notice, there's 4 samples. Let's take a look at that. So there's 4 samples right here, and each of the 4 samples have 5 elements, if you like. So the sample size is 5. This is n equals 5, very important. So sample size is 5, and the number of samples is 4. So there's 4 samples, size 5. Okay, so far so good. Let's read it together. So essentially we want to find out what is the mean of each sample. We're going to estimate the mean and standard deviation of the process. So remember, sigma process versus sigma of the sample. C is estimate the mean and standard deviation of the sampling distribution. D, what would the 3 sigma control limits for the sample be, and the alpha risk. We're going to calculate that. Remember alpha risk? We covered that in the class, last lecture. What's the alpha risk given certain other control limits? Using these control limits, are the sample means beyond the limit? So we're going to plot our chart and we're going to see exactly what that is. Construct control charts. We'll do that together. And then we're going to explain why the control limits are different for the sample means. What we're going to do here is we're going to solve this problem using the sigma that we calculate, and we're going to solve the same problem using the table 10.2. So we'll take it one step at a time, and we'll do that together. Okay, tout le monde. So what I've done is I've worked out the problem as I usually do in post on Moodle, and what I'm going to do is I'm going to walk through how we work it out and where the data comes from and how we solve the problems. So the first thing we can notice is all I've done here is I've rewritten the information from the problem right here. So this is information exactly from problem 1016. So you can see here, here's the samples from 1 to 4 right from the problem. And if you notice, as I mentioned, the sample size here is 5. So the first thing we want to do, as per the question, if we just double check the question, it says A, determine the mean of each sample. And then B, it says estimate the mean and standard deviation of the process. Okay, so let's go back to our calculations here. And the mean of each sample is this. So let's take a look. Here's an example. So each sample, this is sample number 1. What we have is 5 numbers. So the X bar is nothing more than the average of these 5 numbers. So if we take the average of these 5 numbers, we get 4.3. Similarly, if we take the average of these numbers, we get 4.5, and so on. So for each sample, 1 to 4, we calculate the X bar, which is right here. So here's the answer to question A. The other thing that we're going to calculate right away, because we're going to need it later for the R chart, is what is the range for each sample. So here's the R right here for each sample. The range is the maximum value minus the minimum value. So if we take a look at sample number 1, first of all, just to do a little small calculation, the range here, 0.3, is equal to 4.5 minus, which is the largest number, minus 4.2. And that's how we get 0.3 for the range. Similarly, for the other samples, you can see that the range is calculated just by the max value minus the min value, and that's how we calculate the range for each of the samples. The next thing we want to do is we want to calculate the mean of the mean. So remember we talked about the mean of the means? So that's X bar bar right here, and that's R bar. So X bar bar is nothing more than the average of the averages we just calculated right here. So we take these 4 numbers, the X bars, we take the average, it's X bar bar, 4.5 in this case. And in terms of the range, same idea. So the range, we take the average value of these numbers, we take the average, we get an R bar, and that's how we calculate the R that we're going to use in the upper control limit and lower control limits we need to generate the charts. Okay, tout le monde? So I hope that's straightforward. And here's just another way to show it. So you see this equation right here just shows you how to calculate the X bar bar. It's nothing more than the addition of the samples that we have. Okay, next. The question asks for, and we'll just pass right back to take a look at that. B, estimate the mean and standard deviation of the process. Estimate the mean and standard deviation of the process. Okay, so the mean of the process is x bar bar. So that is this answer right here. So the mean of the process, that is x bar bar, is 4.5. And the standard deviation of the process is normally something that you would never have to calculate on the exam. So I wrote over here, if you notice, assume it's given. You don't normally have to calculate the standard deviation. Why? Because it's kind of a tedious calculation. I wrote the formula right here. As I mentioned in class last time, essentially it's a standard formula in statistics. All you do is you take each value and you subtract it from the x bar. In this case, it's the 4.5 divided by the sample size minus 1, and that's how you get your standard deviation. But we're not going to have to do that in this class. So I just provided the answer for you right here. So standard deviation wise, don't worry about that. The important thing is that the mean is the x bar bar. Okay, the other thing is also very important. So let me just pass back here. If you look at C, okay, we're on C already. Estimate the mean and standard deviation of the sampling distribution of the sample mean. Estimate the mean and standard deviation of the sampling distribution of the sample mean. So that is the important part we need for the formula. So the x bar bar is nothing more than the same x bar bar we calculated before, so 4.5, nothing changes. And the standard deviation we want to use for our formulas is this one. Remember we said it's the standard deviation of the process divided by the square root of n. And that is I'll show you right here, and that is the 0.192 divided by the sample size. In this case it's 5. 5 here is the sample size. Right here, sample size items, and that gives us a standard deviation of 0.086 right here. Okay, tout le monde, so now we have everything we need to calculate our upper control limits and lower control limits. Okay, let's take a look at that. So here we go. The question, going back to the question, let's see, D. What would the 3 sigma control limits for the sample mean be? What alpha risk would they provide? Okay, so we'll take it one at a time. First of all, 3 sigma here. 3 sigma means that we need to put z equals 3. So 3 sigma means z equals 3. And alpha risk, as I talked about last class, is essentially the risk of the, if you imagine your normal curve, the area in the tails of the normal curve. And we'll take a look at that, what we mean by that. Okay, so let's just move back here to the calculations. Upper control limit, the 3 sigma control limits are the formulas that I just mentioned at the beginning of this video. So here's the formulas right here. And we simply plug in the values that we have. So we've got everything we need. The x bar bars is the 4.5 we calculated above, right here. And the z is 3. We mentioned z is 3. Z is 3. And the standard deviation over the square root of the sample size is right here, 0.86, allows us to calculate the upper control limit and the lower control limit right here. So we are essentially ready now to draw our control chart. But before we draw the control chart, the question is asking for what is the alpha risk. So how do we calculate alpha risk? Well, let's take a look at this little diagram we did here. So here's your classic normal curve. I drew a little sketch. And essentially, this is your lower control limit. And this is your upper control limit. And this is the center of that, the 4.5. That's x bar bar. My arrow isn't very good here. This program doesn't let me draw nice arrows. But just to give you a sense. So essentially, to calculate the area in the tail, we use these values, just clear that, to determine what is this area in here. And then, of course, 0.5 minus that area gives us the area in the tail right here. And alpha risk, what alpha risk is the sum of the area here plus the area here. And because these two are symmetrical, all we need to do is find out what's the area here times 2, and it gives us the answer. So essentially, how do we do that? We just use our standard z equals x minus mu over sigma. So let's do that. I'll try to draw it over here. So we have z equals 4.758. I'll make a bit of room. Minus 4.5 divided by 0.086. Okay, tout le monde? And if you do that math, you'll see this equals exactly 3. Interesting. It's no coincidence that this equals 3 because, in fact, we chose z equals 3 before. So this was kind of almost like a back check of a question, just to make sure that it makes sense. So the fact that z equals 3, if we look at our tables, we'll see that this area corresponding to 3 is, right here, 0.4987. So 0.5 minus 0.4987 equals 0.0013. So that's one tail. What we want is the area in both tails is the alpha risk, so it's times 2, or adding 0.0013 plus 0.0013 gives you 0.0026 right here. Okay, tout le monde? So I think we're in pretty good shape now. So far, so good. Where were we? Let's go back to the question. So we've calculated D, we've got the 3 sigma limits, we got the alpha risk. Now here's a question E. What would the alpha risk be if the control limits were not the limits that we calculated, but in fact were the limits that they give us in this question? What alpha risk would control limits 4.14 and 4.86 for the sample mean provide? Okay, let's take a look. Okay, so here's the alpha risk. What we do is we just simply, if you like, draw a little diagram. We put these limits in here. We calculate z in the same way. Right here's the formula for z. Okay, we use the same sigma as before. All we're doing is we're putting in the new limits that they give us. We always look at one side, which is why it's 4.5 and 4.86 here that we use. Now that gives us, we'll just clear some of this. Get rid of the arrow. Okay, that gives us, if you look at the tables, a probability of 1. So what does that mean? Alpha is 0. So imagine that. They give us values such that the probability here, in fact, it's totally 0.5. So alpha is 0. Interesting. Okay. Just I guess it's a check as to our understanding of normal curves. Okay, next, let's go back to the question, what is f? So f, they want to know, using the control limits of 4.14 and 4.86, are any sample means beyond these control limits? If so, which ones? Okay, so let's take a look at f. If the control limit is 4.86 upper and the lower control limit is 4.14, okay, let's take a look at what our values were right here. If you notice, the values we calculated here are well within those control limits. So even with those other control limits, all of these values, the highest one is 4.7, the lowest one is 4.3, 4.7, 4.3, fall within these limits. So everything is nicely in control. Everything is nicely in control, no problem. Okay, tout le monde, let's go to the next question. The next question is G. We'll just go check what the question is saying. Construct the control charts for sample mean and sample range using table 2 now. So remember, table 2 is where we don't use the sigma, we actually use the constants that are provided. The question is, are any sample means and ranges beyond the control limits? And if so, which ones? Okay, so let's take a look at that. Here's that table again. If you remember, the sample size was 5. The sample size was 5. So that means we want to use in our equations this for the x bar chart and these for the R chart. So remember those values, and let's move forward here. We'll see that we use that. Okay, and you can see here's the 0.58 that we got from the table for the range, you can see. .325 on the range, we calculated originally in the problem. There's the 0.325 for the range. Okay, and just plugging into the formula. So if you take a look at the formulas here, I'll just clear that out. Formula-wise, x bar we calculated right at the start. That's 4.5. 0.58 is from table 10.2. And this is r bar that we calculated from the start, 0.325. So we get to calculate what our upper control limit is, right here, and lower control limit right here for our x bar chart. And then what we do is we want to plot using the upper control limit here and the lower control limit there. We want to plot our x bar chart. So what we're going to do is we're going to plot the x bars that we calculated before on this chart. Let's take a look at that. Okay, if we go back to the original problem that we had here, the data, I'll just clear that. Here's what we want to plot. There's our x bars, so 4, 3, 4, 5, 4, 5, 4, 7. We want to plot that versus the upper control limit and lower control limits that we calculated. Okay, so you can see that in fact we are beyond the limit. The 4.5 is nice, right, very close to the center line, but these 2 points, the 4.7 and the 4.3, are out. They're beyond the limit. So we have something here which is out of control. This is known as out of control. And if you remember here, coming back to G, the question was, are any sample means and ranges beyond the control? If so, which one? So we've already found that the means, there's definitely 2 which are out of control. Let's check the ranges. We'll go forward here. Let's check the range. Okay, so in a similar way, here's the equation for the upper control limit and lower control limit for the R chart. And here we get again from the table, remember 0 and 2.11, these come right from table 10-2. And because we know the sample size is 5, that's how we choose those. This is the R bar that we calculated before, and we therefore get our upper control limit and lower control limit for the ranges. When you plot that, you'll notice that this is nicely within the upper control limits. So on the range chart, everything is okay. Here's our upper control limit right here. Here's our lower control limit there. Okay, just clear that. And what we're doing here is we're plotting the R's. So I'll just go back to our original problem so you can see that. Clear this. Okay, here's the R's. So we're plotting that on the chart, 0.3, 0.4, 0.2, 0.4. Okay, so you can see here's 0.3 is there, 0.4 is there, 0.2 is there, 0.4 is there. So that's how we plot it. We just plot those within the upper control limit and the lower control limits. I'll just clear that. And in conclusion, all the sample ranges are within the limits, but as you can see here, we do have on the X bar chart that we have an out of limit situation. Okay, tout le monde, so let's keep going. Go back to the question. What's next? So the question was, explain why the control limits are different for sample means in part D and G. So what does that mean? If we take a look at question D again, D was, what would 3 sigma control limits for the sample mean be? So we calculated the upper control limit and lower control limit using the standard deviation sigma for D. So this one we use sigma. And for G, what we used is 10.2. So the question was, how come in D everything seemed to be in control, whereas in G we seem to have something which is out of control? And it's a good question. I would say it's a fair question. And the answer is as follows. So G, and here's the answer right here. So in G, it's based on the process standard deviation only. And the other is based on the range. So the thing is that in table 10.2, the big assumption in table 10.2 is that the process is a normal, standard normal process. So that's the big assumption. And the fact that we have something out of control using the table, whereas we don't have something out of control using the standard deviation, all we could really say is that the process is probably not quite normal. That's about all we can say. So again, I wouldn't worry too much about that question, but it's just an interesting way of doing the same problem using either the direct formulas or using the table. And again, the whole point of this question is, question H, is just to show you that the table is a quicker way to do the calculations, but assumes the process is normal. If it's not, you might be getting incorrect answers. Okay, finally, we're almost there. Let's take a look at the last point is I. Okay, so I is, if the process has a known mean of 4.4 and a known standard deviation of 0.18, what would the 3 sigma control limits for a sample mean chart? Are any sample means beyond the control limits? If so, which one? So let's take a look at that. So they're saying ignore what you calculated in the problem, which is the 4.5. If you remember, ignore what you calculated in the problem and use these values and take a look at the control limits and what does that mean? Okay, so let's take a look at that. So the process mean of 4.4 and sigma of 0.18, when we do our calculations right here, using the new data that we have, okay, so here's your, I'll just clear that. Here's your x bar bar, which is given. Here is your standard deviation, which is given. The sample size is the same. Okay, let me clear that. All right. And as you can see, when you do the calculation, indeed, the last sample is beyond the upper control limit. Okay, so 4.64. Let's go look at the data again. Here is this point. So if we were to plot the chart, 4.7 would have been beyond the upper control limit. So using these means here, indeed, we have a situation which is out of control using these means. Okay, that's about it for that problem. So just in conclusion for this, I wanted to let you know that if you have any questions on this, if you weren't sure about something that I covered in this little video, by all means, just send me an email and I'll hopefully be able to answer your question. I hope you liked it. Hopefully it was helpful. And this is video number 1 of 4. So there's 3 more to go. Hope it was kind of fun. And keep in mind our next class is March 11. That's when we're going to meet again in class. Thanks very much for now.